Today we're talking with Dr. Konorev. Dr. Konorev is an associate professor in the basic science department here at KCU, and he's in the Kansas City campus. Dr. Konorev, would you give us about a 30-second elevator pitch of the type of research that you do?
Yes, certainly. We have several projects that are, being developed in different stages, of development. The most developed one, though, is effect of doxorubicin on the heart. So I would describe it as we are studying the cardiovascular complications of anti-cancer therapy. And the idea is that, cancer treatments and cancer diagnoses, they become more and more effective. And we have more and more cancer survivors that live cancer-free, but there are sort of varying consequences of chemotherapy on their organs and systems. And so we have to deal with that. This is what this project is about.
So when you describe the use of doxorubicin and its effects on heart cells, what kind of models are you using to look at the effects?
Well, we have a variety of models. We use cell culture models, and in those we use human cardiac microvascular endothelial cells and human cardiac fibroblasts. Because we are focusing, I have to say, to start with, on the vascular effects of doxorubicin, because we believe that although, heart failure or cardiomyopathy ultimately is a contractile decline, it doesn't really mean that doxorubicin hits cardiac myocytes first, that contractile elements. The idea is that this might be a secondary effect. And there are a number of cells in the heart that are more vulnerable than cardiac myocytes to the doxorubicin effects. And we are focusing on vasculature and specifically of endothelial cells. And as such, we know that endothelial cells, they are responsible for, they could be studied in such models as sprouting, because sprouting on formation of new vessels is a very important function of endothelial cells. So we have a number of models that kind of attends to that. We have a co-culture model where we co-culture fibroblasts, cardiac fibroblasts, and endothelial cells. In such a co-culture, it's a 2D model, but fibroblasts make endothelial cells to form vessel-like structures. And you can quantify those vessel-like structures as a readout for formation of new vasculature. And we have more elaborate models of this. For example, we have 3D sprouting. In a 3D matrix, we form a gel and immerse beads covered with endothelial cells in it. And then from that monolayer of endothelial cells on the bead, they start forming sprouts into the 3D matrix. And you can also quantify that, how doxorubicin affects that and how our protective interventions would affect that. Still another model is so-called aortic ring, where we excise an aorta from an animal, for example, a mouse. And mouse could be wild type or transgenic mouse, where we have some certain gene knockouts. And here we could study how this genotype, that specific genotype affects sprouting and how doxorubicin affects that and how we can prevent the effect of doxorubicin on sprouting. And again, in a 3D matrix made of collagen gel, we can quantify sprouts that are coming out of aorta. We also have animal model where we inject animals with doxorubicin. And in doing so, we sort of model a chemotherapeutic regimen in a patient. And then we, at some points, at a specific time points, we could excise the heart and study it. Or, for example, by using uh, IHC, immunohistochemistry, or we could excise the heart and isolate certain types of cells from it, for example, endothelial cells. And that way, we would digest the heart into a single cell suspension, and then we will separate endothelial cells using magnetic beads that attach to specific markers on endothelial cells. And then when we have this preparation, we could use that for Western blotting, for example, or we could isolate total RNA and send that for RNA sequencing. So these are our approaches to modeling the doxorubicin effect.
So when you're studying doxorubicin, is there a specific type of cancer that you're more focused on, or are there multiple types of cancers that are treated with doxorubicin, or where are you at on that?
Yeah, so doxorubicin is a very effective anti-cancer drug, although it has been around for a long time, I would say since early 70s. But still, it is considered to be one of most effective chemotherapeutic drugs. And it is being used for a number of different conditions even now, even though we have newer drugs, but still, doxorubicin is part of many, many regimens. For example, breast cancer is often used with it, and this is very prevalent cancer in women. And other solid tumors and a lot of hematological cancers too are being treated with doxorubicin, including those in children. And then we see a lot of negative effects of doxorubicin on children there. So yes, it's very important. Still, very significant.
Sure. In your research, have you found that there may be a type of cancer that the patients are more susceptible to cardiac issues following doxorubicin? Or I would imagine children would have a longer lasting effect, maybe because they're receiving this during heart development.
Right. There are indications in the literature that children obviously suffer from that. But also, I have read a number of reviews on this topic that relate to breast cancer, interestingly. We know that in women with early stages of breast cancer, it was found that they die more often of cardiac disease than cancer. Because, breast cancer right now is a kind of a diagnosis that is not as threatening, especially in the early stages. But then the compounds that are used to treat that cancer leave sort of a mark, induce collateral damage, and these women end up dying of cardiac disease. And cardiac disease could be induced by anti-cancer therapy that was used to treat breast cancer. So I would just say that for me, breast cancer and children's cancer, childhood cancers, I would say, stand out.
Okay. Thank you. It's all very interesting work that you're doing. So if you were to have a student come through your lab who's studying to become a physician, how would you tell them that working in your lab will help them prepare for a career in medicine?
Well, we have a number of students who have had some experience related to chemotherapeutic drugs. They either were treated themselves for their childhood cancers, or their relatives were treated with it, and they saw the consequences of chemotherapy on these cancer patients. I would say that, this project kind of helps future physicians show the dark side of the drugs. if you look at the, you can look at the pharmacology textbook and you will find out how these drugs work, and it's all about the positive effect. But then if they see what this drug at the same time could do to the heart visually, then it may come through to them much quicker, and then they will just appreciate what these drugs are and what just looking from them from a different perspective. I would say that should help.
How many students or residents or fellows have you had come through your lab, or have you worked with in your career? And what are some of the things that they've gone on to do after working with you?
Well, I mean, it's been, I would say, many. I don't have a number. Well, I mean, let's just say just I joined KCU in 2016, and that same year, I had a student as a summer research fellow. Although I just came to KCU, and my lab was kind of a mess at that point because, I was sort of setting it up. But there she was, and she, I wanted to sort of start a project that involves endothelial cells mostly, but she insisted that she wanted to study cancer. And then she's kind of was having kind of a personal vendetta against cancer. And then so I said, okay. And then we have been working on that project over summer. And then she went to present her poster at an osteopathic association meeting, this OMAD, and she got second place there. And it helped her to get a fellowship after she graduated from KCU. So we have stories like that. We have a number of students who went to present on this osteopathic association meeting, national meeting, almost every year. And we have had summer fellows every year as well. We have students from COB who have been doing research elective with us, or we had student volunteers from DO program also that were very helpful and were helping us out. I also have had a grant from NIH, it's called R15, and one of the tasks of this grant, in addition to performing a research project, was to train students. It is a kind of an obligation of this research project to train students. And we have had a number of students, about maybe 2 a year, that were trained and received funds from that grant. And they were student researchers on that project.
Great.
So there are so many different venues how students could participate in this kind of research.
Yeah. Well, if you were able to give students, medical students, one piece of advice, it doesn't have to be about research, just on anything, what advice would you give them?
Well, I think, I will stick with research though. So I think it helps if they have had a prior research experience, because we all know that the DO program is very intense. I would argue that it is more intense as an MD program, because in addition to everything that MDs do, they also have the whole course, which is osteopathic medical manipulation, which takes a lot of time for them to master. So having said that, there isn't much time left for anything else, really. And I would just advise them to look into themselves and figure out what is it that it is most important to them, because you cannot, run in different directions at the same time. So if you want to focus on research, just participate in this dual program. Obviously, this is why you are here, but and do research. Or if you want to do something else, then pick that. So I would just my advice is just to understand what is the most important for you to do, and then focus on it. And if you focus on it and contribute to it on a regular basis, then you will get somewhere in that direction.
Great, great advice. Well, Dr. Konorev, thank you very much for taking some time to meet with me today. It's always interesting to hear about other people's research and all the success that's going on in research here at KCU.
Well,
if you have any,
thanks for your interest. I would like to know about your research too at some point.
We'll have to find someone to interview me at some point, right?
Right. That's what I'm saying. I would like to watch that for sure.
All right. Well, I'll make sure we do one in the future here. But like I said, thank you, and congrats on the success of your lab. And I was looking at your biosketch. I see all the manuscripts that you've had come out recently, and your R21, or excuse me, your R15. That's excellent to have a NIH funded grant. So congratulations.
Yeah, and
on all that.
specifically that it focuses on training of professional students like ours.
Absolutely. Our students really, I think, are wanting to do research, but sometimes they just don't know where to start. So I think your lab may be a good start for some of them.
Well, having said that, we have 440 students, so my lab could be a good one, not for everyone.
Yeah. All right. Well, you have a great rest of your day.
Thank you. Same to you.
All right.